This video is all about simplified medium voltage MV changeover slash interlock system. Recently, I released a video on detailed medium voltage changeover slash interlock system. So now this one is meant to complement the detail type. So it is better to watch the two videos together. I mean this one that shows the concept in block form, and the previous one which shows the detail of the changeover system itself at medium voltage, especially 11 kV. So here it is. But before we move forward, or before I move on, please, if you have not subscribed to my channel before, please do so, and expect more better and useful videos. Thank you. Yes, subscribe to my JK Solutions channel. I expect more useful videos. Now let us go to what today's video is all about, which is a simplified medium voltage, that's MV changeover slash interlock system. Normally, the changeover system comprises three sides or three sections: the main supply section, the emergency power supply or the generators supply sections, which is this place, and then the load section. This is the load side, where we have a RMU ring with the transformers and the feeder pillars supplying the load. And what happens is that immediately there is power interruption, this panel sends a signal through this remote sensing line to this sectional panel LV. So, and this LV panel P signals to the generators to start. So the generator will start and continue to supply power to the load through this circuit breaker, this vacuum circuit breaker here. And then when the power is delivered to this place, this circuit breaker closes and this one opens. Alright? And then with that, power is able to reach this RMU ring and also to the load. Now let's talk about the main supply. This main supply here, we have the incoming circuit breaker, which is also vacuum circuit breaker, PCB, okay, at 11 kV. Then we have a mains metering unit, and then the interlock, which is in green color here. And this is the output of the interlock. This is the common bus section. If it is this one that closes, power is delivered to this common bus section. And if it is the generators that are working, power is also delivered to this bus section. But the two circuit breakers will never close at the same time. When there is no supply from the mains, this one will close and this one remains open. Alright? Then we come to this, we are saying that this system is designed for the power magnitude or power requirement greater than 2.2 MVA. Because if it is greater than 2.2 MVA, then the LV current will be more than 3200, which is the rating of the biggest MCCB that can be readily found in the market. So since it is greater than what this one can cope with, then we have to step it up, and that's what is bringing in the use of medium voltage, which is 11 kV in this situation. So when the output of the generators they pass through this sectional panel, what we call sectional panel is that we have the main bus bar of the panel being divided into sections. So generator, generator, generator. So G1, G2, G3, G4. This one coming here through circuit breaker. This one delivering to this section through this circuit breaker. So this is the panel. Alright, and then we have the outgoing through this circuit breaker. So we have a bus section 1, bus section 2. The sections could be more than 2 depending on the load or the power requirement. If the power is very big, then you can decide to have more sections in order to have the current that circuit breakers will cope with divided into sections. So this one is easier to, I'm saying that making your use of these two circuit breakers to control the current is easier than you looking for a single one at low voltage, and that is why the sectional LV panel is brought into this situation. Now this same panel P is a multipurpose panel, and what it does is that it performs the function of automatic mains failure device, AMF slash phase sequence, okay, slash load shedding, then slash synchronizing the generators. Alright, that is what this sectional LV panel, that is what it does. When there is a mains failure here, there is signaling to it, and there's also signaling to the generators, and then it also detects the phase sequence. If something is wrong with the phase sequence, this signaling will also take place, and it also determines the amount of power requirement, and through that it will determine the number of generators that will be switched on at a time. Alright, now we talk about when there is power supply, when there is a mains failure, that is, there's no supply from the mains, the generator will be functioning, and the power is being delivered through this through the generator system to the load. Now when the power is restored, that is, the voltage is restored from the mains, this remote sensing line also reports to this panel P, and the panel P signals to the LV generator to shut down, and simultaneously this circuit breaker will open and the mains circuit breaker will close. So one at a time. So before, this one was open, and when the generators were working, this one was closed. Now that the power is restored, or the mains voltage is restored, this one will open, and the mains side of the interlock will close. And this is the common bus section, delivering power or voltage to the load. And that is it. As I must have said before, you may want, or one may want to watch this video alongside the one I released on detailed MP changeover system recently. So, and at the same time, please, this MC means no connection. It's just the RMU closing the ring. And that is it. Finally, you must have found the video useful. Please do subscribe to my JK Solutions channel. Thanks for watching.